Let's take a look at question 2. This, by the way, is from 12G in one of the IGCSE Cambridge books. I think it is anyway. And it's asking us to find the equation of this particular graph here. And I've been asked to do this one. This one here. Well, the other ones are very straightforward because they have a very clear y-intercept. So this one's a y-intercept of 1. This has a y-intercept of -1. This has a y-intercept of 2, and so on. But this one here, the intercept appears to be somewhere in between, what is that, 1, 2, 3, 4, and 5, closer to 4 than 5, but it's not very clear exactly the value of that intercept. So the question really is, how do we find the equation of the line when we don't have a clear y-intercept? And the reason I say that is because let's imagine you've got a clear intercept. So let's take, for example, this one here, question 2a, nice and straightforward. Let's have a look at doing that one. So I can just write out y equals mx plus c. We know that c is the y-intercept. The y-intercept here is a 1. So I can just write y is equal to mx plus 1. So straight away I'm on the scoreboard. And now we can just find the gradient here. Well, the gradient, m if you like, is equal to rise over run. So rise is how far from, in this case, the leftmost point. I'm just going to take this point here, and I'm going to go from 1, and I'm going to go, 2 along and 2 up. So my run, 2 along, is going to be 2, and my rise is going to be also 2. 2 along, 2 up, 2 along, 2 up. Of course, 2 over 2 is equal to 1, so m is equal to 1, so I can now pop that in here. So y is equal to, well, 1 times x is just x. I'm just going to put x plus 1, and there is my equation for this line here. So the equation is y is equal to x plus 1. Done. Job finished. Okay. Now, what say, though, we don't have a clear y-intercept? In the case of D, we really don't. So let's have a look at doing that one. In fact, I'm going to just, all right, I'm going to change a bit of paper here because I actually want to have, I'll turn the paper around. It's probably the easiest way of doing it. So I want to be able to write here and for you to see it at the same time. So here we go. So what we're going to do is we're going to define a couple of points. And we have got a couple of points. We've gone at one at -2, 3, and one at 1, 5. So we're able to still do this nice and simply. So I'm going to write y is mx plus c. But this time I'm going to do the gradient first. Well, the gradient will start at the leftmost point we've got, this point here. And I'm going to find out what's the run and what's the rise to get to here. Well, we do the run first. The run is 1, 2, 3. So m is equal to rise over run. And the run is starting here, 1, 2, 3. There it is. And the rise, 1, 2, 3, is 1, 2. So it's going to be 2 over 3. So now we can pop that straight into the equation. Y equals 2/3 x plus c. Or if you like, you just say 2x on 3. Either way, it would be the same. Now, we don't have a c value, but what we can do is we can take either one of these 2 points and use the x value and the y value, or the x value and the y value, and put the x value here, the y value here, and then just solve for c. So I'm going to do that. So let's choose, in this case, I'm going to choose the x value of 1 and the y value of 5. We have to just choose one of the coordinates. I've already done this one here. So let's go ahead and choose this one over here. So x value is 1. And the reason 1's good is because 2/3 times 1 is just, well, 2/3. So, and of course, y is 5. Let's pop 5 in. So let's make y 5. So I've got to have, I'll write the coordinate in here. So coordinate is 1, 5. Here it is. My x value is 1 and my y value is 5. So let's substitute those in now. So y is 5. There it is. So I'm going to rewrite this with a y as a 5. There it is. I've got 2/3 and, of course, times, and my x value is 1. So I'm going to put x for 1 there, plus c. And of course, 1 times 2/3 is just 2/3. So I'm going to have 5 is equal to 2/3 plus c. So now I'm going to subtract 2/3 from both sides. So subtract 2/3 from this side and subtract 2/3 from this side. Now, you can do it that way if you like. Lots of other ways of doing it. I was working with some students today, and one of them said, well, why don't we just multiply everything by 3? And that, by the way, is really probably a much better way of doing it. In fact, let's do it that way now, yeah? So I've got 5 is equal to 2/3 plus c. I like working with fractions, by the way, which is why I was just going to subtract 2/3 from 5. But let's multiply everything by 3, and by doing that, we get rid of the denominator. Multiply this by 3, multiply this by 3, and of course, 3 divided by 3, and multiply this by 3. So now we've got 5 3s is 15, is equal to, we've got a 2 left here, there it is, a 2 plus 3c. So what have we got now? I subtract 2 from both sides, there it is. And 15 minus 2 is 13, is equal to 3c. So I'll divide both sides by 3, there it is, leaving with c is equal to, that's a c, not an e, by the way, it's a c, not an e. C is equal to 13 on 3. Now, I like fractions, so we're going to keep the fraction, and we're going to rewrite the y is equal to mx plus c. Now, we're going to populate this with all the information we've got. So we know y is equal to, well, m we decided, what did we decide it was? 2/3 was 2/3, or 2x on 3. I like 2x on 3, by the way, better. Plus 13 over 3. And there is my equation. Notice equation which we managed to get without going ahead and having a y-intercept. By the way, the y-intercept is 13 on 3. So if you want to know the actual value of that, where is it? It's gone. Anyway, there it is, yeah. So here we are. The actual value, oh, it's gone out of focus 1 second. There it is, yeah, right. So this value here is 13 on 3. So if you work that out on a calculator, in fact, let's just, have I even got a calculator here? Yes, so here we go. So 13 on 3, just have a quick look at what that is. We can do it exactly. So 13 on 3, and we get, let's have a look, 4.3 recurring, yeah? So 4 1/3. So the actual thing is in fact 4, and that actually is 1/3 there. So that value there is 4 1/3. That's the y-intercept. Hope that makes sense.